Hello, GED students. Welcome to the final lesson of Algebra Essentials. Today, we're going to be solving inequalities. And I have good news. Everything we did in the last lesson when we were solving equations is going to apply today. So you're going to get a lot of good review of that skill. And we're just going to give you a couple more tools in your toolbox, and you will be well equipped for the level of algebra on the GED. I've got Miss Annette with me here to make sure that I make sense. So let's start by making sure we know what an inequality is. So let's start with something we know about. We understand equations. We've been dealing with them a lot lately. If I say equation to you, Miss Annette, what am I talking about?
Equal.
Yes, I'm talking about when we have two expressions that are equal to each other. And they can be really simple, like stating 2 plus 3 equals 5 is an equation. It's kind of a boring equation, but it's certainly true. And as we know, and we've seen lately, equations can get quite complex as well. But the main idea being that with an equation, we see an expression equal to an expression. Well, like it says here, not all relationships are created equal. We can have a relationship between expressions that's not one of equality. That's one of inequality. And so let's start with expressions that are just plain old numbers, 5 and 6. Clearly, it would not be true for me to slap an equal sign here. 5 is not equal to 6, is it?
No.
But I could certainly still talk about a relationship between 5 and 6. I could say, well, hey, 5 is less than 6. That is a very simple, if boring, inequality. Obviously, there's nothing to solve here, but we can also solve inequalities the same way that we can solve equations. So for example, if I had the inequality 2x plus 1 is less than 5, even though the left and the right-hand side aren't equal, we have a relationship between the two of them. So we still have the clues that we would need in order to be able to find out, not in this case, one number that x could be, but many. There's a lot of numbers that x could be in order to make the left-hand side smaller than the right-hand side. I'm sorry, some of you guys will be really sad. I know there's a lot of people out there who, when they think about the less than and greater than signs, they think about alligators. But please ditch the alligators. And I have a real reason for that. Let's talk about it. So here we see 4 inequalities. 4 relationships between expressions that are not relationships of them being equal, but of something being larger than or smaller than another. Now, when we just have two little numbers, like we had back in elementary school, like 5 and 6, it's easy to think about, oh, well, my alligator's going to eat the bigger number. There was not a reason to need to read them. However, in the land of algebra, we are going to be reading and writing inequalities that maybe aren't so easy to see which one's bigger. The alligator is not going to be there to guide you. And so you actually have to be able to read those symbols as if they were words. And this can get students scared, but I'm going to show you another little trick you can use. It might not be the alligator, but I've got one. Look up top. We have a number line. On a number line, when we go in one direction, the numbers get larger, and the other direction, they get smaller. So Miss Annette, as I go out this way, what happens? Are my numbers getting larger or smaller?
They're getting larger.
They are. As they move out that way, they get greater. I would go so far as to call this the greater direction. And then as I go the other way, what happens to my numbers?
They're going to go smaller.
Exactly. -1, -2, negative. They're getting smaller and smaller. I would go so far as to call that the less direction. Okay, I'm about to drop the center of the number line. We said this was the greater than direction. Well, guess what? That arrow at the end of the number line, that's the greater than sign. And that arrow at the less than side of the number line, that's the less than sign. They don't come from alligators. They come from our number line. So if you forget which one says greater and which one says less, draw yourself a real quick number line, get yourself oriented. And so what does this first inequality say? It says x is less than 7. And so I know that any number less than 7 would make this true. 6, 2, -5, 1.5. All of those things are less than 7. So all of those things would be decent x's. And you don't have to figure out which one of them that it's going to be. Don't think that way. It just means that all numbers less than 7 are good and true. Our answer here is a range instead of a single number.
Yes, Kate. When I look at the X and then the symbol and then 7, this is where I get confused because I'm like, 7 is greater than X.
Oh, that is true, Annette. 7 is greater than X. You know how I don't scold you when you write X is equal to 6 or 6 is equal to X and I say it means the same thing? You just said something that means the same thing. X is less than 7 means the same as 7 is greater than X. And in fact, we're going to see some problems like that today. But notice what happened when I put 7 on the other side now. My sign, it changed directions because I just put the bigger number first. So now 7 is greater than X.
Oh, okay.
But if I'm just reading the symbols word for word, this says X is less than 7. Let's read the next one then. Next one looks similar. It looks like the same symbol, but it has that little line underneath. That just means that it's okay to be equal as well. So this guy says X is less than or equal to 7. So again, we have a range of answers. It's still everything less than 7, 6, 5, -14, 1.5. All those are good, but 7 is also good now too. Okay, so I'm going to have you read this one for me.
X is greater than 7.
Beautiful. Now let's try this one.
X is greater than or equal to 7.
Gorgeous. So that's the idea, greater than or equal to 7. I need to have at least 7 of something. I need to have at least 7 pizzas for this party. I could have equal to 7 or I could have more than 7, but I got to have at least 7. I'm just going to write down the wording. You can put it in your notes if you want to. One thing I told you at the beginning of class was we're still solving. Today we're going to be solving inequalities. We're still going to be trying to figure out what the X or the Y or the P, in this case, not what it's equal to, but what it's less than or what it's greater than. But still, we're still going to be solving. So all of our wisdom principles from last class, they haven't changed. A lot of times people think, oh, it's a new thing. It's not a new thing. We're still solving. So we're still going to simplify the left and right hand side if possible. We're still going to get variable terms to the same side if they're not on the same side. We're still going to isolate the variable using inverses. None of that has changed. That's all the same. So let's look at 2 examples that are going to feel very, very familiar to you. Like there's nothing new here. First example, solve. 6p minus 4p is greater than 48. Let's bust out our wisdom principles. Wisdom principle number 1, simplify the left or right-hand side if possible. Annette, do you see any straightforward math, any simplifying I know how to do on this time, not either side of the equal sign, but either side of the inequality sign?
There's 6p and -4p.
Exactly. What is 6p minus 4p?
2p.
Gorgeous. 2p is the same as 6p minus 4p, just a simpler version of it. So that's not going to change which side is bigger. And so what you're going to see here is that your inequality symbol is not going to change. It's just stay the same. And now there's nothing to do on the right-hand side, 48. So I did wisdom principle number 1. I simplified left and right-hand side. Wisdom principle number 2 isn't needed right now because we only use wisdom principle 2 when we have a letter on both sides. Well, we only have a letter on the one side. We're good to go. So time for wisdom principle number 3, which is isolate the variable. Take a look at the side where the variable is, that left-hand side here. Is there a number hanging out?
Yes.
And what is that 2 doing with that variable p?
It is multiplying.
Things have not changed. You're still going to do the opposite, in this case, divide, with that same number on both sides to keep your balance. And now let's see what our new, not equation will be, but what our new inequality will be. So multiplying and dividing by 2 are opposites. They cancel. P's alone, just like I wanted. 48 divided by 2 is 24. And now I want to think about this. So I'm going to say Annette has more money than Kate. We both half our money, Annette. But what are we going to end up with if we do that? Well, if you had more money than me and we both spend half our money, you're still going to have more money than me. So the only point I'm trying to make is if I divide both sides of this inequality by 2, I'm not changing which side is bigger. And so we're still going to see a greater than sign. Instead of P being equal to 24, P is anything greater than 24.
How do I know P is greater than 24? Because 24 is a number and P is just a P.
Exactly. You have to know it based on that first symbol. And that's why we can't do alligators anymore. Because we were told this whole thing is greater than that. We can now know that because that was true, it's also true that P is greater than 24. What a good question. So another example, solve 25A is, do you remember how to read this sign?
Lesser or equal to.
Beautiful. So 25A is less than or equal to 5 times the quantity of A minus 40. Wisdom principle number 1. Do you see on either the left-hand side or the right-hand side of the inequality sign any simplifying we can do?
5 times A would be 5A, 5 times negative 40, negative 200.
Lovely. Now all I've done is made the right-hand side simpler. I haven't changed anything, and so that relationship will remain the same. I'll still have a less than or equal to sign. And there's no simplifying to do on the left, so I'll still have 25A. Now, there's nothing left to do, right? I can't do 5A minus 200. They're not like terms. So let's move on to that second wisdom principle. Do we need it this time? So when you look at the left and the right-hand side, are there a letter on both sides?
Yes.
There is. And so we need to get them all to the same side. Now, here is a wisdom principle that I have not taught you before. With equations, I really didn't care if you took it to the left or the right-hand side. But with inequalities, it's not necessary, but you guys just make less errors when you do it. So I would recommend that if you can, get your letters to the left. I am going to move the A term from the right-hand side, 5A, to the left-hand side. We're going to do exactly the way we did before. If you want to move a term, you move it through addition or subtraction. So this is a positive 5A, so I'm going to
Subtract.
And I can do whatever I want as long as I do it to
the other side.
Now, adding or subtracting is not going to change anything. And if Annette has more money than me and we both spend $5, she's still going to have more money than me. Same thing here. If I just subtract something from both sides, I'm going to end up with the same relationship. So I'm still going to have that less than or equal to sign, and I'm going to see what happens on the left and the right-hand side. Well, 25A minus 5A is
20A.
Good. And then on the right-hand side, 5A minus 5A, that's nothing. So I have nothing minus 200 or just negative.
200.
Gorgeous. I got the variable terms to the same side. In this case, I like to get the letters to the left. Last step then is to isolate our variable. Look at your A there. There's a number hanging out, isn't there?
Yes.
How can I get rid of that 20?
We're going to have to divide.
I will. And just like with an equation, I can do whatever I want as long as I keep my relationships the same.
Negative 10.
Brilliant. And again, I've done nothing to change the relationship. Multiplying and dividing by 20 are opposites, they cancel. And I have the statement A is less than or equal to negative 10.
Oh, this is beautiful.
Yeah, it's not bad. It's the same stuff, right? If you have any issues with symbols, like symbols tend to dance on you, watch out for two things. A lot of times, because the inequality symbols don't make sense to you, your eyes, your brain will have a tendency to drop the inequality symbol like it's not there at all. Like your final answer is just A negative 10. And that doesn't say any relationship. That just says there's some mystery number A from which you will subtract 10. That's not what we're trying to say, right? We're trying to say we know something about A. A is not a total mystery. A is less than or equal to negative 10. So don't drop your inequality sign. Does that make sense?
Yes. And that's exactly what I was about to do. So thank you.
Yeah. Really common. It's that thing that we talked about before, that your brain loves you. And so it tries to just skip over things that don't make
Yes.
sense to it and use the rest of the context. And like we've said before, when you're reading a book, that's a very helpful thing. Thank you, brain. But when we're doing math, where every single symbol adds to the meaning, when it does that, it screws us over. So in every new line, I want you to make sure that you still have your inequality sign to kind of override your brain's little drama thing it wants to do. And then the other thing is you might also, this is very common, turn the inequality sign into an equal sign.
I see myself doing that as well.
Yeah. And why does your brain want to do that? Because equal makes more sense to us. Anytime something makes more sense, it's going to be your default to want to use that. It's just like back when we started to use negatives, we would drop negatives left and right. So now we're just starting to use inequality symbols. They're the new symbol that doesn't have a lot of meaning to us. You can watch out for that every time a new symbol is introduced. It will be your default to want to ignore it or change it. Good news is the more you use it, the less that happens. Now, here's my warning. Here's the one new thing that we need to know with inequalities. We're still going to be able to do whatever we want to the left and the right-hand side of an inequality. But some of the things we do can actually change the relationship. We can change which side is bigger and which side is smaller. And if we do that, we're going to have to change which symbol we use. Two ways to change the relationship between the left and the right-hand sides. And one of the nice things is Miss Annette already discovered one of them for us at the very beginning of class. We could change the order of the expressions. So I said earlier, well, when I look at this, that says X is less than 7. And Miss Annette said, Kate, I don't read it that way. I read it as 7 is greater than X. And I said, that's the exact same thing. Now, a lot of students get mad at me. They say that can't be the same thing because the symbols changed. I had a less than sign and now I have a greater than sign. How is that possible? I said, because you put the bigger number on the other side. It's just like me saying Annette has more money than Kate, considering how much money I lose every day on light and salt learning. I am paying for the privilege to work. Well, what if I want to talk about me first? Because I'm a little self-centered. Y'all know this already. Kate has less than Annette. So same thing here. If X is smaller than 7, then 7 is bigger than X. And so if you flip the left and the right-hand sides, then you must flip the sign. So we need to be able to recognize the one in the multiple choices. That means the same as ours.
I may be starting to like inequalities now.
Nothing is that bad when you understand the symbols. But when you don't understand it, everything seems harder than it is. You don't speak Chinese. I do not. You could give me the most simple sentence in Chinese characters and I would just stare at it all day long thinking I'm an idiot. I'm not an idiot. I just don't know what those symbols mean. Let's just start with words and not the symbols. Okay, so if Lucy is older than Mark, then Mark is what?
Lesser.
Exactly. He's lesser or younger, I could say. We know this instinctively when we're speaking English. So if I have more money in my savings account than in my checking account, then I have what?
Lesser.
Exactly. Right. So this is a very simple concept that we understand when we're speaking English, but now we're going to say it in symbols. Example 4. It says solve 19 is greater than or equal to 3m plus 4. So busting out wisdom principle 1, simplify the left and right hand side if possible. 19. Any simplifying you can do over there?
No.
3m plus 4. Any simplifying you can do over there?
No.
Check. Wisdom principle number 2. You want those variable terms to the same side. Take a look at this sucker. Do you have letters on both sides?
No.
So I don't need wisdom principle number 2. I can go straight to wisdom principle number 3. Isolate the variable, get the letter alone. Well, there's my variable m. In order to get it alone on its side of the inequality sign, I have to get rid of the 3 and get rid of the 4. Solving hasn't changed. I have to use opposites on both sides. Remember that when we are solving, we work the order of operations backwards. So I'm going to get rid of anything that's adding or subtracting first.
4.
How could I get rid of that 4?
Subtract.
Beautiful. Now let's see what our new equivalent inequality will be. Look at the left-hand side for me.
15.
Adding and subtracting will never change a relationship. So you have that same relationship of greater than or equal to. And now take a look at the expression on the right-hand side.
The 3m.
Beautiful. Adding and subtracting 4 canceled. Now that it's just 3 and m, I'll divide by 3. And I can do whatever I want as long as I keep the left and the right-hand side in the same relationship. What will my new equivalent inequality be? On the left, I'll just have 5. 3 and 3 would cancel, and m would be by itself. Dividing by 3 is not going to change the relationship between the left and the right-hand side, so I'm still going to have a greater than or equal to sign. And so now I have this statement, 5 is greater than or equal to m. It is alone. We did what we needed to do. So this is absolutely correct. There is nothing wrong with this statement, but it's weird. We usually start with the letter. So when you go to look at your multiple choices, they'll all start with the letter. So you want to make sure that you choose the answer that means the same thing as your answer. I want the m over here and the 5 over there, and I can do that. But because I just flipped the left and the right-hand side, I put the bigger number where the smaller number used to be, and I put the smaller number where the bigger number used to be. So if 5 is greater than or equal to m, then m is less than or equal to 5. So there's that first new piece of information we needed to know in order to solve inequalities, which is if you flip the left and the right-hand side, you've got to flip the symbol. That's half of the new information. But I didn't say there was just one way to change the relationship between the left and the right-hand sides. There are 2 ways. So you could flip the order, or you could do this. You could negate the expressions. Negate means change the sign from positive to negative or negative to positive. So I just want to talk about $10,000. You know how much I like talking about money. You have $10,000.
That's a big number.
But what if I negated that number? I changed its sign. Boom. Annette, you owe me.
You owe me $10,000.
Now it's really, really small.
Yes.
Okay. Annette now does have less money than Kate does. So that's what I mean when I say negating. Changing the sign from positive to negative or negative to positive will change the relationship. But you're like going, when do I negate things? Like my $10,000 never turns into $10,000 of debt, Kate. When does this happen? I'll tell you when it happens. It happens when you multiply or divide the expressions on the left and the right-hand side by a negative number. When you multiply or divide by a negative, it changes the signs. And so if you multiply or divide by a negative, you are going to have to flip the symbol. You just changed the sign on both sides. So you need to recognize that you just made the big number small and the small number big. Now, this is the one that's not as intuitive because in the real world, we don't multiply and divide by negatives as much. This one's a little harder to conceptualize. And so this is the one you're going to be more likely to forget. And so every time we use it, I'm going to write it down because I want to put my voice in your head, like I always say. I'm going to start without the X's because I think it's easier to understand. Now, you're not going to need to do this on the GED. That's not the point. It's just, you know how I am. I like to see a pattern. Can you read this first inequality for me?
0 is less than 6.
Beautiful. And that's the thing we know, right? We know 0 is less than 6. If we added to both these sides, +1 + 1, I would still have a true statement because 1 is less than 7. If we subtracted from both those sides, -1, -1, I'd still have a true statement. -1 is less than 5. I'm not changing the relationships between the left and the right-hand side. Even if we multiplied or divided. So let's imagine we multiplied both sides by 1. 1 times 0 is 0, and 6 times 1 is 6. I haven't made a change. And same thing if I divide. If I divided both sides, for example, by 2, 0 divided by 2 is 0, 6 divided by 2 is 3, I still have the same relationship. 0 is less than 3. So only point I'm making in all that is I added, subtracted, multiplied, or divided. The left and the right-hand side stayed in the same relationship. We still had the smaller number on the same side, the larger number on the same side. But there is a change that I could make that would change, which is the bigger number and which is the smaller number. And that's multiplying or dividing by a negative. So let's imagine that we multiplied both sides of this sucker by -2. What is 0 times -2?
That would just give me a 0.
Beautiful. And then on the other side, what is 6 times -2?
-12.
-12. Now I got a question for you. Which one of these numbers is bigger?
The 0.
0. When you multiply both sides by a negative, you change which number's bigger and which number's smaller. So look what happened to my symbol. I used to have the smaller number on the left, but now the bigger number's on the left. I have to flip the sign.
Boy, you're smart.
I learned. I noticed patterns. Okay,
I
but that's
bet-
not the only time that that happens. It's not just if you multiply by a negative. Signs also change if you divide
Divide.
by a negative. So right now I have the statement 5 is greater than -5. And that's a true statement, but I'm supposed to be able to do whatever I want to both sides.
Right.
So let's just divide by -1, shall we? What is 5 divided by -1?
-5.
Beautiful. On the other side, what is -5 divided by -1?
A +5.
Exactly. Now look at these two numbers, -5 and 5.
Oh, it flipped.
It did. So if you multiply or divide by a negative, you must flip the inequality symbol. So read this statement to me. Think about your number line. So this is this side of the number line, right?
Right.
So am I pointing out in the less than or greater than direction?
Less than.
So read that statement.
-11 is less than -9.
Great. If we multiplied both those, for example, by a negative number, let's just prove to ourselves one more time that we would change the relationship between the left and the right-hand side. What is -2 times -11?
+22.
A whole lot of positive. And -9 times -2?
That gives us a +18.
Beautiful. Not so much positive. And so now which number is larger?
22.
Exactly. And we can see once again, the relationship between the left and the right-hand sides flipped. So this is not a rule that I'm memorizing. If you multiply or divide by a negative, flip the sign, just because some mathematician thought to make up some random rule. It's because that's what happens in life. If you multiply or divide by a negative, the sign changes. So if you were really, really negative, now you'll be really, really positive. And if you were really, really positive, now you'll be really, really negative. So you just changed your relationship. And so you need to logically know, oh, I got to change my sign. Oh, I just thought I'd bust out little Miss Meg, but she's kind of naughty. You start multiplying or dividing by a negative, you're about to flip things upside down on their heads. That little boy's going to fly off the seesaw.
Those two girls. I was fighting with them last week. I was like, come on, girls.
Come on, ladies, play nice together. It's just like parenting. It's hard to get your kids to play nice. It's hard to get simplifying and solving to play nice on the same playground. Now I want to look at, sometimes the sign flipping is straightforward. Sometimes you have choice, and sometimes you see it flipping a lot. And so that can be confusing. So let's make sure we really get this. Next example, solve -5 times the quantity of x minus 1 is greater than 40. We're going to take really good notes on this one, because there are times when you think you should flip and you're not necessarily going to flip. And there's times when you do need to flip and you might forget. First wisdom principle is, if you can, simplify left and the right-hand side. So examine the left-hand side. Do you see any simplifying you can do?
Yes, we can distribute.
Beautiful. We can distribute the -5 or multiply the grouping by -5. So we'll do -5 times x.
-5x.
Beautiful. And we'll do -5 times -1.
5.
There's nothing to do on the right-hand side. Now, what a lot of students will say to me is, Kate, I just multiplied by a negative. I should flip the sign. And I'll say, it wasn't the change you made. That was what was already there. So careful. If there's already a negative there, you're not going to flip the sign. That's not what I meant. I'm still going to see the same sign.
That's when you're simplifying, correct?
When you're simplifying, exactly. It's not till Miss Meg comes out with her multiplying and dividing negatives and her tricky little self that things are going to get thrown out of whack. We know how well-behaved Gemma is. She wouldn't go flipping things around on us. Now, we simplified the left and the right-hand side. Wisdom principle number 2 is not going to help us because I only have a letter on the left. So let's go straight to 3, where we're going to isolate the variable. I have -5x plus 5 is greater than 40. In order for x to be alone, I'm going to need to get rid of this and this. Now, we're solving now. So we need to work in opposite order. We got to work backwards. So is there anything adding or subtracting with x?
Yes, 5.
Beautiful. So we'll move that 5 right there. How?
Subtraction.
Beautiful. And I can do whatever I want as long as I do it to
the other side.
A lot of students say, it's negative, flip the sign. You're not multiplying or dividing by a negative right now. So careful, subtraction doesn't flip the sign because it doesn't flip the relationship. If you have more money than me and we both spend $5, you still have more money than me. So sad. Adding 5 and subtracting 5 will cancel, leaving me with -5x. 40 minus 5 is 35. And I subtracted. That never changes the relationship. But now, Annette, I have one number to get rid of, that -5. What is that -5 doing with X?
It is multiplying.
It is multiplying. So I am going to make a change. I want to get rid of that -5. So I am going to divide by -5. And we've said over and over again that you can do whatever you want as long as you do it to both sides. But the truth is, you can do whatever you want as long as you maintain the relationship. You have to keep it a true statement. And we just made a change where we divided by a negative. Now, remember, when we multiply or divide by a negative, we make big numbers small and small numbers big because we change their signs. And so this is when we flip. So multiplying and dividing by -5 are opposites. They're still going to cancel like they always have, so that X is alone. 35 divided by -5, still going to be -7. Well, what I just did was the change that I made changed the signs, and therefore I must flip the inequality symbol. Instead of a greater than, I now have a less than. So sometimes it's straightforward. There's just a negative over there with a letter and it makes sense. We got to move a negative. But sometimes you have choice. We'll read this first. Solve.
2t plus 5 is less than or equal to 4t minus 7.
Beautiful. So wisdom principle number 1, examine just the left-hand side. Can you make that any simpler?
No.
Beautiful. Examine just the right-hand side. Can you make that any simpler?
No.
Beautiful. So it's time to move on to wisdom principle 2. Do you have letters on both sides?
Yes.
Great. We had talked before when we had letters on both sides. I kept saying to you guys, it doesn't really matter which one you move. It doesn't really matter which one you move. You can move the one from the left to the right or the right to the left, whatever you choose. The same is true here. That hasn't changed. I could move the 2t, take it from the left and put it onto the right. Or I could move the 4t, take it from the right and put it onto the left. It doesn't matter. Now, my preference is you're going to have to get the letters to the left in the end anyway. You might as well move left. But if you moved it the other way, your work will differ along the way, but we'll get to the same place in the end. So I think that I will just move the 4t. Now, I'm not breaking up 4 and t. They're staying together. So when they stay together, that's when we move with add and subtract. So is 4t positive or negative?
Oh, it's positive.
Wonderful. So I'll move it through subtraction. Now I can make changes if I want to, as long as I make them to
Both sides.
Exactly. So I'm going to jump across that inequality symbol and do -4t here as well. And notice where I write it. I write it right under the 2t. I'm combining like terms. Does that make sense?
Yes, but I messed up.
Did you write the -4t under the 5?
Yes.
It's not messing up. I mean, it's still on the left-hand side, but you'll be more likely to mess up on the next step if you write it that way, because you might try to do 5 minus 4.
Okay.
It's a lot to remember. We're back on the freeway, and now I'm teaching you even more crap. Now it's rush hour, girl. Woo!
No.
So what is 2t minus 4t?
That's going to give me -2t.
Beautiful. Now you haven't done anything to that +5, so it's still going to be there.
Always look up, you say, right?
Exactly. When you get lost in algebra, you just look up. It's just like life.
God is good, ain't he? Even in math.
Even in math. Okay, so take a look at that right-hand side now, that expression on the right. 4t minus 7, but I took away the 4t, so what do I have left?
Oh, the -7.
Beautiful. Now, subtracting never, ever, 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 never, ever changes the symbol. Now, we got the letters to the same side. It's time to get the numbers away. We're solving, so we're working that order of operations
Backwards.
backwards. Move anything adding or subtracting with t first.
5.
Exactly. So I'm going to move the 5 first. How could I move it?
Subtract.
Wonderful. What will my new inequality be?
-2t.
Beautiful. And on the right-hand side?
-12.
Beautiful. And now, again, careful, subtracting doesn't flip the sign, so I will still have a less than or equal to inequality sign. Now, t's not alone yet. There's that -2. What is that -2 doing with t?
It is multiplying.
Beautiful. I will do the opposite to get rid of it, so I will.
Oh, divide.
Good. What am I dividing by? Divide by exactly what you want to get rid of.
-2.
Brilliant.
Now, that's a good note to put in my head.
Divide by exactly what you want to get rid of.
Yes.
Now's when I really, really want you to pay attention. You just divided by a negative. Can I still do that with inequalities? Yeah, you can. As long as you remember that multiplying or dividing by a negative flips the relationship. You just made big numbers small and small numbers big. So you better
Flip
find.
the sign.
That's what I'm saying when I say careful. Some actions have consequences.
But you don't
So
do that till the end, right?
I'm going to do it right now on the next line.
Oh, okay.
Multiplying and dividing by -2 are opposites, they cancel. T's alone just like I wanted. And I will flip this now because I just divided by a negative. And so instead of seeing less than or equal to, I'm going to see greater than or equal to. And now -12 divided by -2, you
Positive 6.
good. And so now I have T is greater than or equal to 6. Now I'm calling this one experience level practice. It's not actually that bad, but I'm going to need to be really careful with your inequality symbol in this particular example, because it is possible to see both types of relationship change in the same problem. The one where we flip the sides and the ones where we negate. Let's take a look. It says solve 19 is less than -1/2 times the quantity of 6x minus 2. So first thing, do you see any straightforward simplification I can do?
On the right-hand side, oh, we can distribute.
Exactly. We can distribute that -1/2. And feel free to do it in your calculator. What is -1/2 times 6?
-3x.
Exactly. Nice. It wasn't just a 6, it was a 6x. So I have -3x. Now I need to do -1/2 times -2. Really common error to drop one of those negatives. Careful.
That gives me a 1.
So I'll write +1. Okay, no simplifying to do on the left-hand side. And simplifying never, ever, 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 ever changes the inequality symbol. So I simplified my left and my right-hand side. Well,
I'm thinking the -3x.
what were
So
you thinking I could do?
I'm thinking about moving him right over there.
Oh, okay. So you actually could do that right now. You could add 3x to both sides, but it's not what most students think of. And
Okay.
probably actually your way would be faster and have less errors. But I'm going to go the way most students go because I want you to see that double flipping that happens because it
Okay.
messes students up a lot. So right now, I only have an X on the right-hand side. A lot of people are going to say, well, hey, wisdom principle 2 done. And so I'm not going to bother to move the X term back and forth across the equal sign because he's already on one side. I'm just going to go straight to isolating him. I want to get rid of the -3 and the 1 in order for X to be alone. Which one of those numbers should go first?
The 1,
How could I get rid of him?
we're subtracting.
Good. So I'll subtract 1. So that +1 goes away, and I can do that as long as I keep my left and my right-hand side in the same relationship. 19 minus 1 is
18.
And then on the right-hand side, what am I going to have over there?
A -3x.
Good. Subtracting does not change the symbol. X is not alone yet. I still have a -3. So I want to get rid of it. So what's the opposite?
Division.
Good. Divide by exactly what you want to get rid of.
-3.
Gorgeous. So multiplying and dividing by -3 are opposites. They cancel. X is alone just like I wanted. And 18 divided by -3 is -6. But realize you just made a change.
And I flipped because it's a -3. When
You flipped because you divided both sides by -3. When you multiply or divide by a negative, it changes the signs on the numbers, so you must change the inequality sign.
not when I subtract or add.
Exactly. So I'm going to see a flip there. It's not going to say less than anymore. It's going to say greater than. But this is why I wanted to do this problem with you, Annette, because this is true. This is right. There's nothing wrong with this statement. X is alone, so it is solved. However, it is weird. We usually write inequalities with the letter on the left. My final step here would most likely be to flip the left and the right-hand sides. Well, what did we learn? We learned that if we flip the left and the right-hand sides, we flip the sign. And so that's why I'm saying that sometimes, depending on how you do your work, you could see the sign flip twice. This is the thing that students write me about most often. They say, Kate, you're a liar. All the time. They say, you told me that when I multiply or divide by a negative, the sign flips. And it didn't flip in this problem. And I say, it's not that it didn't flip, it's that it flipped twice and you missed the second one.
Well, how are
So
you supposed to know when if you've already, because see, when you did the first flip, I'm thinking that's it. That's the end of the problem. So,
yeah, it was though. This is done. You could have stopped here. -6 is greater than X. However, that's not what the answers will look like in the answer key. Since mathematicians almost always write these with the letters on the left, you're going to see it looking like this. And you're going to need to recognize that if -6 is larger than X, then X is actually smaller than -6. So if I need to flip my answer around to match it to the answer key, then I got to flip my sign again. There's ways to avoid that. And that if I had done what you wanted me to do at the very start, which was add the 3x, I would have actually avoided that. So
okay.
it's not like there's this set in stone way you have to go. There's a lot of freedom when we're solving. However, you have to know if the thing you chose to do affects which side is bigger and which side is smaller. Two things will affect that. If you multiply or divide both sides by a negative, or if you flip the left and right hand sides. And if you do both in the same problem, well, guess what? You just flipped it twice. Let's look at example 8.
I'm going to take a picture of this one. This is exactly the type of problem they give you.
An art supply store lists its prices for printing and framing in the table. Sita wants to frame a 15-inch by 20-inch original artwork in cherry, and then print and frame as many 8-inch by 12-inch reproductions as possible. Solve the inequality 42.98 plus X times the quantity of 4.98 plus 9.98 is less than or equal to 250 to find the number of reproductions, X, she can have printed and framed and still stay within her $250 budget. Now, I got to tell you, the biggest enemy that you're going to have in this problem is actually worry and anxiety and overwhelm. This is actually quite a simple example, but it feels like so much because we're looking at so much. But look at what they tell you to do here. So what are they asking us to do or to find?
To find the number of reproductions.
And they even tell you how. They say do something to find the number of reproductions. What do they tell you to do?
Solve the inequality. Well, then
What
why do we have to have all those words up there? That's what really mixes you up.
It
Yes.
is a really big skill to be able to pick through and see what you need. With this passage in this table, I could ask you 100 different things. The particular one they asked me about was super simple. I didn't need all the other junk, but they could have asked me something where I needed to go find the junk. But in this case, they wrote the inequality for me and they told me solve the inequality. Right now, I could just start with the symbols and do the algebra. Take a look at that left-hand side, Miss Annette. I say we can make this thing a whole lot simpler. Do you see any straightforward math we know how to do? Look inside the grouping.
Well, we could add those together.
Exactly. They're plain old numbers, aren't they?
1496.
Good. I just made this piece simpler, but this thing in parentheses is still multiplying with X. And then we still have that 4298 that it's adding with. And I have not done anything to change the inequality sign or the right-hand side.
We keep the parentheses.
I'm glad you said that actually, because I think that's what I'll do next. When we want to multiply together a number and a letter, we don't usually write X parentheses 14.96. We write it more simply, don't we? We write the number first, 14.96, and the letter second. That would be a simpler way to write X times 14.96. And now that is still adding with 4298, and it's still less than or equal to 250. Now, this is a lot easier on the eyes, right? That's why we simplify before we start solving.
But why'd you put the X at the end when you had the X at the beginning of the parentheses?
What's X times 5?
5X.
Same thing here. What's X times 14.96? 14.96X.
Ah, okay.
Now, examine the left-hand side. Is there any more simplifying I can do?
No.
No, those are not like terms. I cannot combine them. Beautiful. So I'm done with that first wisdom principle. Simplify as much as you can before you start solving. Now it's time to start solving. I can see that there's only an X on one side. So all I got to do is get the numbers away. Let's make sure to move anything adding or subtracting with X first. So this 42.98 is separated from X by a plus sign. That's the thing adding or subtracting. I'm going to get rid of it by doing the opposite. I'm going to subtract 42.98. Now I can do whatever I want as long as I do it to both sides. Make sure you get all the way across the inequality symbol. Okay, let's see what our new inequality will be.
207.02 on the right-hand side.
Beautiful. And how about on the left-hand side?
We're going to bring down the 1496x.
Beautiful. I still have 14.96x. And I subtracted. Subtracting never, ever, ever affects the inequality symbol. What number is over there with x?
1496.
What's he doing?
Multiplying.
So I will
Divide.
Beautiful.
On the other side as well.
Cool. It's about to get ugly.
Yeah, 13.838.
Okay, now how about the left-hand side?
We just have an X there.
Have we done anything to affect the inequality symbol?
No.
Beautiful. So we have this statement. Now, if we were in the land of pure algebra, we'd be done. We'd just say X is less than or equal to 13.838, whatever. But we're in the real world. And take a look at my multiple choice answers. At least 13.
Oh,
no more than 13. At least 16. No more. This is when the context helps us in that. So let's go back up to the question now. What were we looking for?
Find X.
And it says that X is what? It says to find the
number of reproductions.
There you go. We're looking for the number of reproductions, X, that she can have printed and framed and still stay within her budget. And we see our answer here says X, the number she can have framed, has got to be less than or equal to 13.838. Well, what does that thing mean? It means reproduction. So now we got to go find the answer that makes sense. Well, I say two of them have the wrong number.
C and D.
Exactly. Okay, now I want to talk about the language at least and no more than. Because what a lot of students want to do is they see the less than symbol and they want to go straight to at least. Means the same thing, they think, right? Less, least, gotta be.
Right.
But think about what at least 13 means. If I say, I want you to have at least 13 of something, can you be equal to 13?
Yes, you can.
Yeah. Can you be less than 13? Not if 13 is the least you're allowed to be. At least 13 means I want you to have 13 or more. And then I will bring you at least 13 flowers. Well, you're not hoping for 13, girl. You're hoping for 30, right?
Okay.
So watch out for that and put it in your notes because that's confusing to students. At least actually means greater than or equal to. And at most is less than or equal to. And that makes more sense. Think about going shopping. You never have to buy at least something. Well, unless it's shoes. I have to buy at least 5 new pairs of shoes, girl. But if you're trying to stay in your budget, you can usually buy no more than something. So this girl can buy no more than 13 reproductions. If she buys more than that, she's going to go over her budget.
Well, see, for one, I'm thinking about rounding, but I don't see rounding anywhere in this problem.
And again, it's because it's the real world. You want to round up to 14, right?
Right.
Get out of math and come with me to the art store. You ready? Girl, let's go shopping.
Okay.
Okay. You go to the art store and you go to them and you say, hey, I have enough money for 13.83 reproductions. And my math teacher said that if I have most of the money, you have to give me the 14th one. They're going to say, sweetheart, I don't care what your math teacher said. Come back when you have all the money. So yes, most of the time, 13.8, we'd just call it 14. But if we were shopping, we wouldn't be able to. Nobody says to you, well, okay, you have more than half the money, have it. I'd like to do that with cars. You just go in and you're like, I have $1 more than half the money. Give me the car. My math teacher said so. No. Why do we need all these words around this? Can't we just solve the inequality? It's like, yeah, we can solve the inequality, but we need the words around this because this was a real life scenario. And sometimes real life scenarios, they have real life restrictions. Like you can't buy part of a reproduction. X is less than or equal to 13.838 means that practically this woman cannot buy more than 13. Art store again.
Oh, Lord, another one.
This one's actually easier.
Is it?
Looks harder because it scares people because look at the way the answers are.
Yes, yes,
Yeah,
yes.
we're writing inequalities, but it's actually not that bad. So let's take a look. Example 9. Mark plans to purchase an easel for $62.95 and frame three 16-inch by 24-inch paintings. Write an inequality that could be used to find y, the maximum price he can pay per frame, if he wants to keep his purchase under $220. So we're writing an inequality. That's what they've asked us to do or to find. The inequality is going to have a y in it. And they're telling us that when we use y, we're talking about the price that he can pay per frame. Okay, now we do this all the time in life, right? We know we have a certain budget we have to stay within. This is a very good example of inequalities. I want you first to look at the part that's the same in all these inequalities. They all have something, and then this symbol. What does this symbol say, Annette?
Lesser than
Exactly. So something is less than
$220. Okay.
something is less than 220. Something is less than 220. Something is less than 220. Okay, now look at this last phrase. If he wants to keep his.
Purchase under.
So knowing that, it's nice because I'm realizing what I need to figure out how to do is mathematically, I need to be able to figure out what his purchase would be. What do we know about his purchase?
Well, he bought an easel for $62.95, but he needs three frames.
Mm-hmm.
And then not only that, Mark doesn't know whether it's a simple, cherry, or teak.
Exactly. So, but what does Mark know? He knows he's going to spend $62.95 and he's going to buy three frames. So
Okay.
we need one that says that.
Oh, okay.
So I'll tell you one thing, they love to do this to us. They took some numbers that look really tempting and threw them into a couple of the inequalities, numbers that we didn't need. We're talking about his purchase right now. We're talking money. But a couple of these have numbers thrown in that have nothing to do with money.
A and B.
Exactly. 16-inch by 24-inch. You don't multiply your inches together to figure out how much you're going to pay. That's just nonsense. Can we just at least rule out A and B?
Yes.
Beautiful. I'd love to get nonsense out of the way. Now, I really like it now because it looks almost the same with C and D. What's the difference between C and D?
The Y.
The Y. In one of them, the Y is multiplying with 62.95. We're paying 62.95 Y times. And in one of them, the Y is multiplying by 3. The Y is happening 3 times. Let's go back and look at our word problem. What do they say Y is?
The maximum price per
Right.
frame.
Mhm. In C, they have us multiplying the price of an easel times the price of a frame. And in D, they have the price of the easel plus 3 prices of the frames.
This is D.
Exactly. You'll pay for the easel once and you'll pay for 3 frames. That's what that says. The things we're saying are exactly what we do in life. Annette would go in and say, I want 1 easel and 3 frames, and I need it less than 220. That's exactly what that says. I want 1 easel and 3 frames, and I need that to come in under less than 220.
16 by 24 has absolutely nothing to do with nothing.
So all they're doing is making this real life. In real life, we know that we have to use certain numbers to find certain pieces of information and other numbers to find others. Now, what if I didn't send you to the store, but I sent you to the wood shop and I said, Annette, I cannot afford any of these store-bought frames. Could you please build me a frame? Now, all of a sudden, it becomes way important for you to know it's 16-inch by 24-inch.
Right.
So it's important to know where you're going in order to properly select your information.
Well, it's called mathematical reasoning.
It's like you are advertising for the GED test, Annette. It's a mathematical reasoning test. They want to see if I throw a bunch of information at you, do you know, like, oh, if I just need to know this is all I need. Pluck, pluck, pluck. I don't need all the rest of that jazz. Okay, this is our last one. And this is another one that looks way harder than it is. So I want you to breathe. This might be the easiest example we've done all day. I'm going to read it first. Solve 31 is less than 3x minus 5, which is less than or equal to 40. Now you're going to notice that I made this the only advanced example today. So if you never get through this, this is not a big deal. It used to be on GED practice tests on some older versions, but it no longer is. And I've had a lot of people telling me that they haven't seen it on the newer versions of the test. So technically it could show up. It probably won't. But if it does, I just want to show you it's actually really easy. But what I need you to notice here is that there's two inequality symbols this time. There's this and there's this. This can happen with inequalities. We don't see it so much with equations. We don't usually say three things are equal. But you can do it with inequalities because it's like, now I'm not just talking about your money and my money. I'm also talking about Ted's money. So it's like, well, Kate has less than Annette, but Annette has less than Ted. And that's what this says here. It says 31 is less than all this jazz, but all this jazz is less than or equal to 40. It's a relationship between three expressions.
But I see 4.
Oh, because of the 3x minus 5?
Yes.
Oh, I'm glad you said that. Remember to break it at the inequality symbols.
Okay.
It might be complicated, but that's still three expressions. Your eyes stop when you see an equal sign or an inequality sign.
Okay, I see what you're saying.
All right. This time, instead of having two expressions in a relationship with each other, I have three. But my goals are the same. My goal is to get the letter alone. So look at where the letter is. The letter's in the middle. And the nice thing is, on these examples, on the GED at least, you will always see the letter in the middle. And so it's always going to be your goal to make sure the letter is the only thing in the middle. In order to do that, I have to get the numbers to go away. And there's two numbers there. There's a 3 and there's a -5. And since I'm solving, I will move in the opposite order like I always have. So I'll move anything adding or subtracting first. So look at that letter, X. Is there anything adding or subtracting with X?
The -5?
Exactly. That's who I'm going to move. And I'm going to move it like I always have. If I want to cancel out, subtract 5, I add 5. But here's the deal. I don't just have two expressions in a relationship anymore. Now I have three. If I change one of them and I want to keep the relationships the same, I've got to change all three. So I'll go add 5 over here.
Okay.
And I'll add 5 over there.
Over here.
Now it's going to be really important that you really only pay attention to one piece at a time as we go to write the new inequality. So completely ignore the middle and the right for me and just look at the left.
36.
Gorgeous. Now, adding doesn't change anything, right? So I'll have the same symbol. Now completely ignore the left and the right now and just look at the middle.
I have a 3x there.
Exactly. Subtracting 5 and adding 5 are opposites. They cancel. I've got just 3x there. And now I didn't do anything to flip the inequality symbol, so I'm still going to see a less than or equal to. And now completely ignore the other two and just deal with that third expression.
And I'm bringing down 45.
Beautiful. Now you can see X is almost alone in the middle there, but there's a number hanging out. What number is hanging out with X?
3.
Beautiful. What's 3 doing with X?
It is multiplying.
Good. So if I want to get rid of him, I should.
Got to divide.
Beautiful. And I can do whatever I want as long as I keep that relationship between all the expressions equivalent. So if I divide by 3 on the middle expression, I'm also going to do it on the left expression and the right expression. I've got to keep all 3 expressions this time in the same relationship. And let's see what our new inequality will be. So again, just one piece at a time. Look at the left. Simplify that for me.
That's 12.
Good. I divided, but it was by a positive, so that won't change. Look at the middle.
That's just going to be an X.
Gorgeous. And again, I've not done anything to flip the inequality sign. That'll be the same. And now look at the right.
15.
Beautiful. And now this is my final answer. X is alone. He's alone in the middle, but he's still alone. So basically what this says is between. Do you see how X is between two numbers?
Yes.
X has to be between 12 and 15. And this happens in life too. Like, meet me between 2 and 3. It could be 2, it could be 3, but it could be anywhere in between there. That's what that says in common English. Somewhere between 12 and 15. How many people will come to the party? Well, I don't know. Probably 12. That's too small, but I'm sure that it'll be less than or equal to 15. Putting them in order basically from least to greatest when we have these compound inequalities like this. So really, for most people, even if you lasted with me to the advanced practice, if you can do the beginning level practice, you are fairly well equipped for the GED. You're doing 90% of the inequality problems. Now, if you really are sitting there like the beginning was too easy,
Mm-hmm.
okay, try the experience where I throw those word problems at you like that flip and frame store. That's cool too. We definitely see word problems on the GED, tables on the GED. All right, you guys. So what do I want you to do now? I want you to do what I always want you to do, which is go practice. It is just the fact of the matter that if all you ever do is watch other people do it, you're not going to get good at it. You've got to practice yourself. Don't worry if you struggle. If it seems challenging, that means you're working your brain, you're sweating. Just like we sweat in sports, we struggle through mathematics, and that's how we get stronger. And so that's actually a good sign. You're getting stronger. Yeah, we're done. This is the last class. So once you finish this, you're going to go on and you're going to see some reviews, and then make sure you use the guide in the back of the book, or if you're using the website, last page of the website, to decide if you're ready after this unit to take your test. Each unit stands alone, so you may well be ready to test and not need anything more.